Let's talk about concavity. Now, I'm going to give the definition first, and then I'm going to use a series of pictures to try to explain it. So here's the definition. If the first derivative is increasing, in other words, the second derivative is greater than zero, then the function is concave up. And I'm going to highlight that, concave up. Okay, so I want to draw a couple of pictures to try to capture what I mean by concave up. So let me draw a picture that looks like this. When we look at this picture, my function is clearly increasing, so my f prime is greater than zero according to this picture. But when I look at the slopes of the tangent lines, you have one slope that looks like this, we'll have one slope that looks like this, we'll have one slope that looks like this. So when I look at this, the slopes are getting steeper and steeper. Slopes are getting steeper and steeper. So what does that mean? That tells us that our first derivative is increasing, which tells us that our second derivative is greater than zero, right? The first derivative is increasing, something that's increasing, its derivative is greater than zero. So the derivative of the first derivative must be greater than zero. Let me draw a similar but slightly different picture. Let's say that I look at this curve right here. Okay. If I look at this picture right here, what do I notice? Well, the first thing I would notice is that this function is decreasing. So when I look at the first derivative of this graph, that's going to be less than zero. But when I go to draw the tangent lines, if I draw a tangent line here, that is negative. That's quite negative. It's downward sloping. When I look at the derivative at this point, it's still negative, but it's less negative. And when I look at the derivative at this point, again, it's still negative, but it's less negative. So again, my my actual first derivative is still increasing. So my first derivative is increasing still. And that tells me that the second derivative is greater than zero. So in each of these two cases we have over here, our second derivative is positive. But this first example, the function's increasing, and the second example, this function is decreasing. So in this situation, do you see how these both kind of cup upwards? So this is why we call it concave up. All right, let's look at the next situation. The next situation is going to be the concave down situation. So, so if f prime is decreasing, in other words, the second derivative is negative, then the function is concave down. And I'm going to highlight the concave down just like I did the concave up over there. All right, so let me draw a couple of pictures to help you understand this situation. You know, we could draw something that looks like this. We could draw something that looks like this. And I hope you can see that on this curve on the left, again, my first derivative is still positive. This function is increasing, right? But when I look at the tangent lines, this tangent line is steep. This tangent line is less steep. This tangent line is even less steep. So the slopes are getting less and less steep. Okay, so what does this mean? This means my f prime is decreasing, which means my second derivative is less than 0. If you look at this picture on the right, I have the same situation. I have a slope that's slightly downward sloping. The next slope over here, this is even more downward sloping. This next slope over here is even more downward sloping. So when I look at this situation, my first derivative this time is negative, but my f my f prime is decreasing, and this basically tells us that our f double prime is less than 0. Okay, so in each of these situations, I hope the picture helps you see that one situation is concave up, so these guys are cupping upwards. The other situation is concave down. These guys are concave downwards. And an easy way for you to remember all of this is the following. Positive things make you happy. So this means the second derivative is positive, means that it's concave up. Negative things make you sad. So that means when the second derivative is negative, that's concave down. All right, cool. I think this is a good place to stop this video. Let's talk about inflection points on the next video. Take care, everyone.